Hello guys. So we have come almost to the end of this lecture, like this course basically. So this is the last module which we are going to discuss. This module is called classifications. So classification is something which all of us know, right? It is something which we use in our day-to-day life. In our day-to-day activities, we get to see that we classify things, we classify objects. Even as a child also, initially when the child just starts learning things, so basically at that time the child doesn't know what is, if I talk of animals, child doesn't know whether it's a cat or a dog. So maybe the mother teaches the child, see, this is a cat, this is a dog, and so basically once he or she gets when the child gets this knowledge that okay, this particular animal we call it cat, this particular animal we call it dog. So next, gradually when the child grows up, the child can automatically, whenever a child sees an animal which the child has already known the level of the animal, the child can identify, okay, this is a cat, okay, this is a dog, this is a cow, whatever it is. So these are this classification, it starts from the very beginning of our life. So this classification we get to see in many aspects. And coming to the technical aspect of it, like why we are going to learn classification basically, and in many of the disciplines, many engineering disciplines, many social science research, many things in many domains, medical domains, we really need to classify some observations, classify objects, classify data. We need to classify data based on some classify data into some basically relevant categories. So now the thing is that, so why do we classify data to some relevant categories? We classify object to some relevant categories. We classify some observations, different kind of some image. That may be various reasons. Maybe for some medical diagnosis, maybe some medical research, from social science research, and then maybe some business perspective, for personal use, and maybe for security reasons. For different types of data, we may have different security requirement. Like say mail, we may need to classify a spam mail and a non-spam mail. So all this is what is called classification. So we are going to learn, definitely all the algorithms is not possible to learn in this course. So we'll be learning a couple of algorithms, how we classify different objects, different observations, different data. So in this lecture, first we'll be covering the introduction to classifications. Then there are two different categories of classifications. That is, we call it supervised classification and unsupervised classification. We'll be discussing that in this lecture. And then finally, I'll give a formal statement of supervised classification technique. In this lecture, I'll restrict my discussion to only supervised classification technique. Unsupervised classification techniques I'll not be discussing. Okay, so now coming to the introduction of classifications. Okay, first, now see, there's a picture. I am asking you to identify the objects. Now, how you will identify these objects? Of course, as now you already know what are these objects. So that this is an apple, this is an egg, this is an onion, this is a potato. All of us, we know, we can directly identify these objects. But the thing is that how did we identify this object? All these objects, it has some characteristics, it has some features or parameters or attributes, whatever you say. It has some distinguished feature, each type of classes. When I call it a onion and when I call it a potato, each has some distinguished characteristics, that which we call it a features. Based on these features, we try to classify the objects. Okay, this is an onion, this is a potato, this is an egg. Based on these features, we do that. So now if we need to identify these objects, since this it is already we already know what's when we call a thing as onion. So when we see the features matches, okay, then this is an onion. Okay, that's how we identify the object. Now again, there are some other way also where sometimes when we identify some data, classify some data, it may be not, I should not say this characteristics. Basically, it is some sort of rule. Using some sort of rule, sometimes we classify data. and rules means it is again specify some sort of features as well. Like here, if you see, we am classifying the marks of the students. We as a teachers, we always do. We give the grades to, after exams, we give the grades to the students. How? Based on the marks. When the marks is greater than equal to 90, we give A grade or excellent grade, whatever it is. From 90 to 80, we give B grade. So this is nothing. This is again one sort of classification only. Here, how we do the classification? It is directly by rule based. It is very much deterministic. Okay, this marks above this is A grade, between this and this is B grade, this and this is C grade. It's a very deterministic rules are there. Based on the deterministic rule, we specify these are the different classes of marks, different classes of students, grades. So this is one way by which we can classify data. Once we have seen, we can classify data based on some features, its distinguishing features, distinguishing attributes. And another is that we can also classify this way based on some rule base. If that's how we are framing the rule, basically again based on some features. Features maybe this if we can consider as marks greater than 90, this is a feature. Okay, so but this is nothing. It's just I have made a specific deterministic rule for that. So now, again, some example, if you see, like from life science, I already mentioned in classification is very much used in case of medical research, medical diagnosis, like predicting tumor cells as benign or malignant. How the doctors, how the radiologists does that. We do MRI. Based on the MRI data, this is what they basically do some sort of image processing. So how do they do? There are different features, so they try to identify different features, and they have the knowledge that okay, this features means this features imply this. So based on the different features, when an image is given, so based on the different features, they try to identify okay, this is a benign tumor, this is a malignant tumor. Fine. Okay, and then next, coming to some example of security credit card transaction as legitimate or fraudulent. Okay. Okay, credit cards, sometimes what happens, usually an average person uses credit card every, maybe once in a week, or every second day, or every third day, and even average middle class person takes out money, say around every week. If a person uses a uses maybe the card, ATM card, and then withdraws money, say around 5,000 or around 10,000 per week, or every alternate day. So suddenly, and for the same card, if it is found that it is withdrawing a lots of money in a very short intervals, at every half an hour, it is at exit hour, suppose the person has withdrawn 1 lakh, again after half an hour it is withdrawing another 2 lakhs, again after half an hour or 1 hour it's withdrawing 3 lakhs. Very frequently it's withdrawing a huge chunk of money. So and this machine can understand that this may be a fraudulent transaction. Maybe this credit card has got stolen, and that's why the person who got hold of this credit is using it this way. So this can be this is how this transaction can be classified. This is a legitimate transaction. This may be a fraudulent transaction. Okay. Similarly, in case of, it has many applications. Classification is something, it has varied applications. Like now, again, we can think of in the weather prediction. Like satellite, what has the satellite collects data? It collects the data of humidity, wind speed, pressure, wind speed, humidity, and many other factors. Like it collects different data, and then based on this data, it can classify. Okay, the next day it will fall in which car. It will be a cloudy day, sunny day, whatever it is. So these are the different features. It tries to take the value of the different features. Based on different features, it tries to identify it. Okay. Similarly, entertainment, categorizing news stories as finance, weather, entertainment, sports, etc. Okay, you have noticed when you if you are a user of YouTube, if you use YouTube, usually in YouTube a personal profile gets stored. Profile meaning the person's browsing history gets stored, and so when a person, if I load the YouTube and if some other person load the YouTube, the videos which I'll get, it will be different from what the other person will get. It's because on the things, the stuff I browse, it basically tries to keep a history of that, and based on that, it categorizes into my choices. It has been categorized into a particular classes. Maybe I see lots of news stories. So when I try to load YouTube, I'll get to see a different types of news in my the screen. Similarly, some other person, maybe whenever he opens the YouTube, he usually watches movie. So maybe he watches new movie. So whenever he loads the YouTube, whenever he opens the YouTube, he will get to see all the different new movies that has come, that has been loaded. So that's how it categorizes the person's based on the features of the person browsing history, it categorizes the preferences of the person. So this here also we use classifications. Okay, so now let me formally, we've seen lots of examples of classifications. So let's formally define what is classification. So classification is a form of data analysis to extract model. Okay, it's a form of data analysis to extract model describing important data classes. Okay, so it's a form of data analysis to extract models. We'll have to analyze the data and we'll have to extract a model. We'll have to find a model. Basically, it's a black box, a model. What is the what will the model describe? It will describe important data classes. So given an input, it will give the which data, it belongs to which data class, C1, C2 or C3, which data class, it belongs to which data class. So that is the formal definition of classification. Essentially, it involves dividing up objects, whatever objects or observations or data, whatever it is, so that each is assigned to one of a number of mutually exclusive and exhaustive categories known as classes. So given an object, it will be assigned to one of the mutually exclusive, exhaustive and exclusive categories known as classes. Means when given an observation, given an object, it will be assigned to only one class. It will not be assigned, one object will not be assigned to more than one class, and each object will be assigned to one of the classes. Okay, it will assign to one of the classes, and one object which is assigned to one class, it will never assign to some other classes. So it is mutually exhaustive and exclusive. The term mutually exhaustive and exclusive simply means that each must be assigned to precisely one class, that is exclusive. Each object must be assigned to precisely one class, and that is never to more than one and never to no class at all. Never to no class at all. This exhaustive. Okay. So now, as I told you before, the classification consists of assigning a class level to the set of unclassified data, and this classification broadly it can be classified into two different classification. We can have broadly, there are two different techniques for classification technique if you see broadly. So one is called supervised classification and the other is called unsupervised classification. Now what is supervised classification? Supervised classification is a data with possible class of each is known in advance. Okay, so like as the example what I have given initially when I started with classification, a child is taught this is this element, this is this animal, this is cat, this is dog. So that is in supervised classifications. So the child tries to put it in the child's brain. Okay, these are the features. When these features are there, then it is called a cat. When these features are there, then it is called a dog. Okay, so this is the data, features are known as well as its class level is known. For a particular set of features, this is the class level. This then we call it a supervised classification. Like your apple, suppose it is round shaped, it is red colored, and I mean whatever may be the features, whatever, and so then this is called an apple. Okay, so it is again round shape. If it is yellow color, then maybe it is an orange. So it is based on this attribute, is round shape, red color, round shape, yellow color. These are what? These are attributes, these are features. And what is the label? Label is apple, orange, these are labels. So data with possible class of each is known. Data attributes, based on the attributes, what is the class, it is known. And then in such a case, and then in next, when we give in data with an unknown label, then it will be able to identify, okay, this belongs to this class. This is called supervised classifications, where the classes level are known in advance. How many classes are there, that are known in advance. The next is unsupervised classification. Unsupervised classification is something like class leveling of data is not known. Given a data set, first of all, we don't know how many classes will be there. What will be the different class level? Nothing is known to us. Just the data are given. Somehow when the data are given, we try to group the data in such a way. Okay, the big data set is given. We try to group the data in such a way the data belonging to a group are very much similar to each other compared to the means all the objects belonging to this group are quite similar to each other in its features, whatever maybe in some of the features, than compared to the object belonging to the other group. Okay, so like I can give you an example. One unsupervised classification, a very good example, classic example actually. It is used from long time back in data mining. We basically use this customer segmentations, like in a in a retail shop, a big retail shop. So daily data is there, or monthly data. We see monthly data. Monthly data means huge data. Many customers has come, many customers has purchased many things. So the huge data, customer purchase data is data. So we don't know from this what sort of classes we can bring out, and how many classes we can bring out. Nothing is there. The data, what is this data? Data is customer purchase history. From this, if we try to group data and there can be different grouping. Now, as I told you, it tries to form a group so that the characteristics of the object within a group are very much same. When we compare the characteristics of the object belonging to some other group. So like here, maybe one group, maybe people who are buying only electronics goods. Then there are some people who are only buying groceries. There are some people who are only buying cloth material. So this may be, we can somehow group this way. This may be one group, or maybe some other grouping. Maybe people are buying. When people are buying one X, usually they are buying Y also. So this can be one group. So again, some other group, maybe some customers, they were quite active before. Now they have completely stopped. So, but on the contrary, there are some customer who is quite initially there was no activity. Now they are very much active. So this way the different groups. These different groups, basically it is called clustering. So unsupervised classification, basically we call it clustering. We form different clusters. Okay. So this is we will not be discussing unsupervised classification in this course. Basically, we'll restrict our discussion only to supervised classification. So unsupervised classification, the basic idea I have given, I think you could understand that. So okay, so now, okay, this is one good example of supervised classification. Here different emojis are there. So it's different emojis according to its level of the emojis are also given. So when we see the first emoji, say this emoji indicates a good friend. So when we get this sort of icon, similar kind, so once we know, okay, this means a good friend. So if I get, okay, that means this belongs to this class. Okay, so this is supervised learning. Again, unsupervised classification, you see here there are different cats. Okay, so now how will you all are cats only. So like as I told you, in a retail shop, all are data only, purchase data, all are purchase data. How to classify this data, how to think what can be the different classes of this data. Similarly here all are cats only. Now how to classify this data, how to make different clusters of this data. Maybe we can have some some cats which have, say, blue eyes. So this is a cat which have blue eyes, this is a cat which have blue eye. So okay, is there someone else? No. So maybe cats with a blue eyes, we can have one cluster. So then cats with a brown eye, we can have another cluster. So that way, if we make the cluster based on the eyes, or maybe based on some other features maybe. So that way, but cluster level is not known, how many classes will be there, it is not known, then we just try to find out, we just try to make the group with the characteristics that object within the group are very much similar, and it is compared to the object belonging to the other group. Okay. So supervised, when we talk of supervised classification technique, so now any technique, first we need to know what is the input of this technique. First, in any technique, first what should be the goal of this technique, why at all we are thinking of this technique. Okay, so why at all we are thinking of this technique, that is the first thing we should know. Then only we will start preparing things, right? Okay, then that is goal that is known. Now then, what will be the input to this technique? Okay, and what is the input to this technique? And then, okay, given this input and this is the goal, this is the input, this is the goal. Now what it will do to the input so that we get this goal. So now for supervised classification technique, what is the input? Input is a collection of records. We also call it a training set. Okay, it's nothing but a collection of records, collection of different observation of data. If I talk it in case of statistics, it is this collection of different observations. Okay, so each record contains a set of attributes, and among that, one of the attribute is a class. So it's a collection of observations, and this observation, each observation has some attributes, and one of the attributes is the class level. And what is the task? Find a model for class attribute as a function of the values of the other attribute. That means we have to find y is equals to fx. I have to find these functions. This x are the attributes. For function of these attributes, this x are the attribute. For this attribute, if these are the attributes, then what is the class? Basically, I have to find out y is equals to fx. That is my task. For given attribute x, what is the class? First, initially, for some, so that I can understand before going to classify the things, I should understand the stuff. Okay, this things belongs, this things means it belongs to this class. So that for that is we have already modeled, we have already trained it ourselves. So once we have trained ourselves, like the child that trained it, so then this is our task. What is the goal? Previously unseen records should be assigned as class as accurately as possible. So task is given a set of observations. This observation has also the class level. So from this observation, we have to find this function y is equals to fx. For this class level, what is this function? Somehow we'll have to find this function. Once this function is known, then what is the goal? Given any unseen record, where the class level is not given, just the attributes are given, we have to assign the class as accurately as possible. And how we will assign the class? Satisfying the property of mutually exclusive and exhaustive. A class has to be assigned to one, observation has to be assigned to one class, not more than, an observation cannot be assigned to more than one class, and each observation has to be assigned to one class. Okay. So this is an example, like say there are different, we have total 15 observations. So these are the different attributes. We have total 4 attributes. Okay. So for 15 observation, we have 4 attributes. The first 3 I am calling it attribute 1, attribute 2, attribute 3, and the third one and the fourth one I am calling is a class. So for these values, this is the class is no. Okay, let us consider there are 2 classes, no and yes maybe. So this is my, sorry, first I have say 10 observations. In the 10 observation, all the attributes, values and the classes are given. Using that, I'll try to understand, okay, if this is the features, then this is the class. Okay. Once that is known, then given a test set, given any attribute value, I should be applied to tell, I should be able to tell, okay, this belongs to which class. Okay. So this is induction, learning model, and this from this model, I'll apply the model and I'll get a deduction for these classes. Fine. So now to define it formally, the same thing, given a database D, it has some tuples. What is this? T1 to Tm, different tuples, and each tuple is nothing but a set of attribute. Each tuple consists of a set of attribute. T1 is a set of attribute A1 to AN, T2 is a set of attribute, another set of attribute A1 to AN, different attributes. So, given a database with a set of tuples, and each tuple is defined by a set of attributes and a set of classes, given a set of tuples and a set of classes C, the classification problem is to define a mapping from D to C. What is a classification problem? Classification problem is nothing, just a mapping from the set of tuples to a set of classes. Okay? Where each TI is assigned to one class. It is not that a TI will have no class assignment. Each TI has to be assigned to one class. Okay? So, note that the tuple TI belongs to is D is defined by a set of attributes. Fine. So, now the number of classification techniques, I am talking of supervised only. So, based on supervised classification techniques are known, which can be broadly classified into following categories. So, what are the different methods we know? One is statistical based method, distance based method, decision tree based method, error based method. So, statistical based method, basically we use statistical based method when we basically try to identify the level of a class when based on some known relevancy, based on when we know this some class with known level, some objects we know some object with known level, and some other objects we try to put classify that object under some classes based on the relevancy of the known class level. Okay, so here in statistical method, basically it is not very deterministic, like if this attributes are there, then definitely it will go to this class. It is not that. It is deterministically, we cannot say, like for an apple, we can deterministically say that if it is if the size is of this to this much inch, and this color is this, shape is this, and top is this, bottom is this, then definitely it is an apple. Like deterministically we can say, but in statistical based methods, such deterministic rule doesn't apply. Actually, we cannot say if this is that, then it will belong to this class. So, in statistical based method, we try to just find out the relevancy of what we have to predict and what already we know. From what we know, we try to predict based on the relevancy of that. Okay, so that is the reason in statistical based method usually we use probabilistic terms. So, we will see, and one of the most used statistical based method is called Bayesian classifier, which we will be discussing in my next lecture. Okay, then next is distance based method. So, in distance based method, here how we try to classify the objects, we try to classify the objects based on the similarity index. Like if I tell a cat and a dog similarity index both has 4 legs, 1 tail, then 2 ears. So, the similarity index is quite similar, isn't it? So, as it then the similarity index means both will belong to the same group, but at the same time there are some features which will significantly differentiate between the dog and the cat. So, there the similarity index will be quite different for some other features which will differentiate between a cat and a dog. Okay, so this similarity index we usually define in terms of the distance of one attribute, distance between 2 attributes, one attribute from one object and one attribute from the another object. When we try to find out the distance, the similarity index we try to find out the similarity index, we usually consider the distance of these 2 attributes. So, based on this distance based method, one of the approach is k nearest neighbor, which we will be discussing in I think the after 2-3 lectures. Okay, then next is decision tree based method. Decision tree based method, it is very much like a rule based, what I have told initially at the beginning of this lecture. So, if this, then this, sort of that, the rule based actually. So, here what we do is that from the attribute set, we try to find out one attribute which when we go on continuously splitting those attributes, so that it forms a sort of tree. Initially, For the best classification, first is the good selection of an attribute which will act as a root node. So first we'll find out the attribute, one attribute, and then we will try to, based on that attribute, we'll try to divide by using some rule, we'll try to branch it to different other nodes. Then again from that node we will further go to different other nodes. So and gradually we will reach a leaf. So that is basically the classes. Okay, so distance tree based, that is a distance tree based method. However, in distance tree based method I will not be discussing in this lecture. So then the fourth is the error based method. Error based method I'll be discussing support vector machine. It's a very important classifier. I'll be discussing the support vector machine in a couple of lectures. Okay, and so coming to the conclusion, in this lecture we learn about the basic introduction of the classification tasks, the idea of supervised and unsupervised classifications I also have put, and I have also put this taxonomy about some popular classification technique. Okay, in the next few lectures we'll look into the working of some such classification method. Okay, these are the references, and thank you guys.